So, I'm here to do a video on trigonometric functions. I just felt like I need to do one because I didn't have a electronic video for a long time because I had lots of stuff to do. So I just basically learned about how trig functions work and that kind of sort. So first I'm going to cover basic trig functions, and then we are going to go into the reciprocals of trig functions. So here we have imagine that this is a plane, okay? So I'm just going to write just put that. So basically trigonometric functions are used in triangles, especially right angle triangles mostly. You can also use it for other acute triangles, but still you prefer to use it in right triangles mostly. So you have basic three trig functions to start off with. They are, as you may have heard, sine theta, cos theta, and tan theta. They don't include theta though. They just are like sine, cosine, and tangent. So theta is the basic symbol used to represent an angle in trigonometry. So what is sine? What is cos? What is tan? How do you evaluate them? That's what I'm here for. So I'm going to teach you how these functions work. So for sine, it is so. Cos is ka, and tan is toa. Okay, so let me say what these stand for. O is for opposite, so O is for opposite. Let me just write that. So sine is equal to opposite side over hypotenuse. So in a right angle triangle, that is the hypotenuse, and you know which is the adjacent and which is the opposite, which I'll be showing it to you in a minute. And ka is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, so for example, you had this angle as theta. Say that's A and that's B and that's probably C. So your sine theta would be opposite over hypotenuse, which is, let's say, opposite is that A, and hypotenuse is C, A over C. Cos theta is going to be adjacent, so that's the adjacent side, B. Adjacent is the next side, and hypotenuse is C. Tan theta is opposite or opposite or adjacent, A over B. So yeah, that's it, is the basic trig functions. So we can do lots of problems with them, which I'm just going to do it now. I'm just going to do one basic problem. I always like to write SOHCAHTOA so that it is easier, but once you practice many problems, then you won't need to use them. SOHCAHTOA. Okay, so say you have a triangle, a right angle triangle with a angle of 20 degrees and a side of, say, 2, probably here. Okay, so first we need to find the sine of 20 degrees, which is sine of 20 degrees is equal to, so opposite is 2, over opposite over hypotenuse, which is, let's say, is A, and that as B. So over A. A is equal to sine 2 over sine of 20. 2 over sine of 20. And you can calculate it using a calculator. I have it. Yeah, I need to go get it. It's right here. So you have 2 divided by sine of 20, and it gives me 2.1907. See, I think you can probably see it. It's so bright. Let me adjust the brightness. Yeah, 2.1907. So I usually like to round it off to the nearest 1000. So it's going to be 2.19. 2.19 approximately. It's approximately 2.19. So A is equal to 2.19. So now we have to find B. There are several ways you can solve for B. You can either do it using the Pythagorean theorem, which states that a squared plus b squared is equal to c squared, or you could use the trig functions. Well, I'm going for trig functions because we are doing trig functions right now. So opposite or hypotenuse system, so we need to find b. So b is the adjacent side. So what includes adjacent sides? It is ka and toa. So you can do both of them, you can try out both of them, but I am going to go for cosine. So cos of 20 is equal to adjacent side, which is b, over hypotenuse, which is a, which is equal to b over 2.19, as we just figured it out. So now we are going to do b is equal to 2.19 cos of 20. So you have to multiply cos of 20 degrees with 2.19. So cos of 20 times 2.19, I get 0.8936. 0.8936, so I'm gonna round it off to 0.894. B is approximately equal to